Okay, this is part 4 of the arc and angle relationships lesson, and we're going to look at the when the angle is inside, and we're only going to look at this section right here. And if you have two chords that intersect inside of a circle, and just as a note, it could also be two secants that are actually going through the circle. So you could have a whole secant going through and a whole secant going through, creating that angle inside of the circle. Doesn't necessarily have to be chords. But the two pairs of angles formed inside of there are creating what we call vertical angles. And y'all should be pretty familiar with vertical angles. So you know that these two angles, angle EA or EBA and CBD, are going to be congruent because they are vertical angles. Well, there's also some information about the relationship between the arcs created by those chords and the angle that is created. So the measure of any one of those angles is equal to half of the sum of the measures of the intercepted arcs. I'm going to highlight those arcs. So if you have arc AE here and arc CD right here, if you add those two arcs together and get their sum, and then you take half, that will be able to give you the measure of this angle AEB. So in this case right here, the first one, you're looking at the measure of angle ABE and the measure of angle DBC. Well, since those are congruent, then it's just going to be the same measure because those two are vertical angles. Now, for the next one though, it says that the measure of angle AE is 60 degrees. And the measure of, I think I said angle there, measure of arc AE is 60 degrees. The measure of arc CD is 40 degrees. It may help you to kind of write in those numbers. And so if you add those two numbers together, you get, of course, 100. 60 plus 40 is 100. If you take half of that, that would give you 50. So the measure of that angle would be 50 degrees. Well, it gets a little trickier down here because you are given the angle. On the third one here, you are given the angle and you are given one arc. So let's go up here and label them. And I've erased what I had. So maybe you want to draw another circle to demonstrate the third example. But I'm going to write for the measure of arc AE, I'm going to put a 75 right there. And the measure of angle ABE is 55. And we need to know what the measure of arc CD is. What I would suggest you do is to rewrite the equation and substitute what you can. So substitute under the measure of angle ABE, put 55 degrees. Because you already know what that is, you're not solving for that this time. And the measure of arc AE is 75 degrees. And what you have to find is the measure of arc CD. Now, in order to solve this problem, the best thing to do to start out with is to get rid of that 1/2. So to get rid of that 1/2, instead of dividing by 1/2, you might think of multiplying times the reciprocal. So we would multiply times 2 on both sides, and that makes the 1/2 disappear. And now you have 110 is equal to 75 plus the measure of arc CD. And then once you subtract 75, you would get 35 degrees for the measure of arc CD. I highly suggest that when you are solving these, that you write the formula out every time and substitute what you know and solve for the missing piece. Because in the second one, all you had to do is find the angle, but the third one got a little trickier because you were trying to find another piece on the right side that was missing. So I'm going to write 35 degrees, and we will conclude that section, and that's the end of this video. And then the last part we will look at is the angles outside of the circle.